Welcome back, folks, to lesson 51 of the Dead Earth game development series, brought to you by the Game Institute. In this lesson, we are going to do quite a lot of stuff. We're going to add a stamina system to our FPS controller rig, so that when we run, we use up our stamina and we have to wait for it to recharge. We're also going to create the player HUD that is going to be used by our Creeper minigame. In many ways, you can think of this lesson as being the first lesson in the development of our Creeper minigame. You'll notice also that, like I said I was going to do at the end of the last lesson, I have now created all of the different zombie controllers, all 4 of them, so that we have our zombies all animating using different animations with different settings. And if you want to download this project before this lesson, I would recommend doing so. You can get that from the Game Institute website. I think it's called Lesson 51 Project so far. And that will just make sure that all of your zombies start off in the exact same state as mine, in the same locations, and with the same controllers and settings applied. But of course, you don't have to do that. If you want to just carry on using your own project, there's nothing saying that how I've set up my zombies is in any way optimal, but that's where I've placed them for the Creeper game. And of course, if you download the project, you also get the animator controllers that I've set up. But I did ask you to go and do that yourself, and hopefully between the last lesson and this lesson, you did that and you didn't have any problems with it. Okay, so before we get started, just one other thing that's worthy of note is you'll notice that when I place the zombies in the scene, there's 3 zombies: the zombie clown, the zombie yaku, and the zombie mutant, that are disabled. I'm not going to use them in the Creeper game. The reason being is that the Creeper game is actually quite difficult, because the player only has, as a weapon, the ability to push zombies away. Mix that in with the fact that we have limited stamina, and the fact that our zombies are actually pretty intelligent, and when they see you, they don't really want to let you go. The game became extremely difficult. So I've decided that I'll leave them in the scene so that you can enable them if you want to, and they've all been set up, so we can just turn them on if we want. In fact, I'll do that now. Let's turn on the different zombies and press play with all of the zombies active. And you'll see, I think over here we've got, somewhere along here, we've got the zombie clown. There's a zombie clown there, look. Imagine him coming at you and laughing maniacally while he does it. And I think we also have zombie yaku. That's him there with the samurai sword through his chest. So they all work, they've all been set up, but like I said, the game was a bit hard with them, so I'm going to delete mutant, yaku, and clown. Or not delete them, but just disable them. All of these zombies have been prefabbed now with all of their new settings. And like I said, if you want to carry on using your own project and not use this project, then you can always download this project anyway. You can open it up and you can use it as a reference, so you can see how I've set the speeds, for example, of the various states of each zombie. Because one of the things that's really cool about our Omni Zombie controllers is the fact that we could have multiple zombies using the same animator controller, but we could set one to patrol using a speed of 1 and another to patrol using a speed of 2. And of course, they'll use different animations within that animator controller, and it will look like they've got completely different controllers. So it makes 4 controllers look like we've got 12 controllers, and that's really cool for creating variety in your level. Okay, so I'm going to disable lighting again in the scene view so I can see what I'm doing much more clearly, even though it looks horrible. And we will get started on adding stamina to our FPS controller script. Because stamina is very integral to how the player moves, this is not going to be in the character manager, which is more of an overall manager, but it's going to be in the actual FPS controller script, which of course is the script that deals with all of the FPS physics and moves our player and detects whether it should be running or walking. So it's in our FPS controller script that we're going to add variables to deplete and to recover stamina, and also use that stamina to affect the speed at which our FPS controller rig moves. So if you select the FPS controller rig game object in the scene hierarchy, and then double click on the FPS controller script to open it up in MonoDevelop, we can get started and start adding this stamina system. So here we are inside our FPS controller script, and the first thing I'm going to need to do is add 2 new variables to our inspector assigned locomotion settings block that's going to allow us via the editor to set the stamina depletion rate and the stamina recovery rate. So I'm going to put these, I think, just underneath where we define crouch speed. Doesn't matter where we put them, I'm just putting them here because that's how I like them to show up in the inspector. And we're going to add 2 new floats. They're both serialized fields, so they show up in the inspector. And the first one is called stamina depletion, and I'll set this to 5 units per second. So that basically means as we're running, we're going to lose 5 units of stamina from a possible 100 every second. And the stamina recovery, I'm going to set to 10 units per second. So when we're running, we're going to be subtracting 5 from our stamina. And when we're not running, when we're doing anything else, 10 per second is going to be getting added to our stamina, back up to a maximum of 100. The other thing I'm going to add here, which has nothing to do with stamina, is at the moment in our start function, if I remember rightly, we automatically assume that we wish the flashlight to start in an off position by setting its active status to false. This should probably be something that we can control in the inspector. So back up in our inspector assigned locomotion settings block, underneath where we define the flashlight game object, I'm also going to add a new serialized bool called flashlight on at start and set that to true by default. In a moment, we'll update the start function, so instead of just assuming it's false, it will actually set the status of the flashlight to whatever the value of this boolean is here. Okay, so we've got a stamina depletion and a stamina recovery rate, but what we actually need now in our private variables block is a variable where we will actually store what the current stamina of the player is. So I will create a private float, doesn't need to be serialized, called stamina, and we'll set this to 100 so that at level startup, the player has the maximum amount of stamina. I'm also going to add another variable now, which isn't going to make a lot of sense at the moment because we're not going to use it for a while, but I'm going to call this freeze movement, and it's a boolean that will allow any external script to tell the FPS controller that we don't wish it to move. This is really useful for if your character controller is part of a cut scene. We might not want the FPS rig to move away from that location, especially if another character is talking to you, but we still want the character to be able to look around using the mouse. And in Creeper, we use this at the very end of the level. Once we've achieved all the goals, we go back to the elevator and the elevator starts moving up and the game is then complete. You've escaped the zombie infested level. However, when we're moving up on that elevator, we don't really want the player to be able to move or jump off of the elevator, because if the player does jump off the elevator is never coming back down again and there's no way to complete the level. So when that elevator starts moving, we'll freeze the movement of the controller so the player is rigidly stuck on the spot on the elevator moving up, but the player is able to still look around using the mouse. And we're going to create some properties now that will allow us to fetch the stamina and also set and get the freeze movement boolean value. But like I said, we won't be using freeze movement just yet. So let's add some properties that will allow us to get the stamina, because our character manager is going to need to be able to inquire about what the current stamina of the FPS controller is, so it can do things such as pass that information on to the player HUD. So I'm going to put these properties, I think, underneath where we define our character controller property, so just above the start function. And the first public property I'll create is the one that allows us to get and set the value of this freeze movement boolean. Nothing there you haven't seen before. And as the second property, it's just going to be a getter that returns what the current stamina of the FPS controller is. Next up, I'm going to move down into the start function. I'm going to find the line of code where at the moment we hard code the fact that the flashlight starts as off. And I'm going to replace that with that new variable that we just added called flashlight on at start. So we can now control via the inspector whether we wish the torch to be on or off at startup. Okay, so now let's move into the update function where we calculate the stamina. I'm going to scroll to the bottom of this function. Just remember, the update function is where we do things such as process any input to turn on and off the flashlight. It's where we also ascertain what the current state of the player is. So you can see it's this conditional here where we check if it's currently not grounded, if it's grounded but it's not moving, if it's crouching, if it's walking, or if it's running. And just above where we calculate the drag multiplier, this is where I'm going to calculate the current stamina. So what I'm going to do is this. I'm going to say if movement status equals running, well then we know we need to deplete the stamina. So I will say stamina equals, and I'm going to wrap this in a mathf.max so that we never let stamina fall below 0. And inside the mathf.max, I'm just going to say stamina equals stamina minus the stamina depletion rate multiplied by time.delta time. And as the second parameter to the max function, I'm going to pass in 0. So we're basically saying subtract stamina depletion rate times delta time from stamina, but don't let it fall below 0. But then we're going to do an else clause as well, because if we're doing anything else other than running, then we actually wish our stamina to recover. So I'm going to wrap this in a mathf min so that we never allow the stamina to grow beyond 100. And inside the mathf min, I'm simply going to say stamina equals stamina plus the stamina recovery rate multiplied by time.delta time, and then passing in 100 as the second parameter to the mathf.min function so that we don't allow ourselves to increment stamina past the maximum of 100. So every frame, our stamina is either going to be moving up towards 100 and clamping at 100, or if we're running, it's going to be depleting setting down to a minimum of 0. With our current stamina now calculated, let's now move into the fixed update function, which is the function that actually moves the character, and change the way we move based on whether our stamina is depleted or not. So you can see that we have this line of code in our fixed update function, which I'm sure you will remember, where we calculate our current move speed. We currently say if we're crouching, then use the crouch speed. Else, if we're walking, then use the walk speed, otherwise use the run speed. We need to change this bit. We don't just want to use the run speed, we want to use the run speed scaled by our current stamina. So what I'm going to do is I'm going to put some code in here that looks like this, and then I'll explain it. Okay, so what I'm saying here then is if we're crouching, use the crouch speed. If we're walking, use the walk speed. However, if we're not doing those two things, then we must be running. And in the case where we're running, we wish to take our stamina factor, which is our stamina divided by 100. So in other words, a value in the range of 0 to 1. And we wish to use that as the t value and alert between our walk speed and our run speed. So if our stamina is at 100, we're going to be using the run speed. If our stamina is 0, we're going to be using the walk speed, even when we're running. And if our stamina was 50, well, then it's going to be halfway between the walk speed and the run speed. So that's our stamina system complete, and we'll test that in a minute, and we'll be able to see that as we start to run, we eventually run out of steam and will reduce to a walking pace. And of course, later on in the lesson, when we add the player HUD, we're also going to see our stamina depleting in the HUD as well, so we can really see what's happening. But the final thing we're going to adjust in this function and in this script is where we calculate the movement direction speed. You can see at the moment, we take the desired movement vector, multiply it by our speed, and then multiply it by our drag multiplier. But we also need to do something else here, factoring in that new freeze movement boolean, because if the freeze movement boolean is set to true, then we don't want to allow movement on the x or the z axis. So what we would do is this: we will say if freeze movement isn't set to true, in other words, if not freeze movement, then we will use what we used before. We will set movement.x to desired movement.x multiplied by speed multiplied by drag multiplier. Otherwise, we will set the movement direction x to 0. So if freeze movement is true, the x movement will be 0. And of course, we need to do the same for our z movement direction as well. We'll say if freeze movement isn't set to true, then just do what we did before. Otherwise, clamp the z movement to 0. We've now made all of the alterations that we need to make to our FPS controller script in this lesson. So let's save that off and go back to the editor and check we haven't got any errors. And we haven't. And if you look in the FPS controllers inspector now, you can now see we have the stamina depletion rate, the stamina recovery rate, and we also have the ability to turn on or off whether or not the flashlight starts on application startup. I think we will turn that off so that when the level starts... No, actually, I'm going to leave it on. Okay, so let's press play now, and I'm going to maximize on play, and let's see if we run out of steam. I'm going to try running from the start. As you can see, I've now slowed right down. And now I'm just reduced to a walking pace. So now I'm going to stop running, and we should see our stamina start to go up again. Of course, we can't see it on the HUD at the moment, but if I just wait a few seconds and start running again, I should get some of my speed back. Yes, I do. Perfect. This is going to be pretty scary in Creeper when you're trying to run away from a zombie. Oh, look at him. He's coming at me. Oh, little Girl Scout to see me. Oh! Holy shit, that scared the crap out of me. That really scared the crap out of me. I didn't expect the maniacal butcher to be behind me. Okay, so let's now create the player HUD that is going to be used by Creeper. It's going to be a very simple HUD that just has a place where it can display our health, our stamina, where it can relay any information about interactive objects that our mouse cursor is currently over, and also where it can relay mission critical information. So it's going to be a very text-based affair. But hey, it's going to do what it's designed to do, and it's also going to be taking us one step further towards the final HUD that we're going to use in Dead Earth. So we already have a very basic HUD that we created many lessons ago. At the moment, our basic HUD contains just one element, a text element that we use to draw this crosshair in the center of the screen. If we select the game object in our hierarchy called Player HUD, we can see that we've already created the master canvas object, and it has a single child object, a text element that has that plus sign that gives us this crosshair in the center of the screen. If we step up for just a moment to the parent object, we need to configure the canvas a little better. You see, at the moment, we're using a very simple canvas scalar mode. We're using a constant pixel size. Doesn't matter too much for our crosshair, but you'll notice that as I shrink the screen in to a really small size, the crosshair doesn't actually change size. So if you imagine we were to zoom that little window up really big, we'd see the crosshair was now massive on the screen. What we want is for all of the elements on our UI canvas to scale with the size of the screen or the display mode that is chosen. So we're going to change the UI scale mode of the canvas scalar component from constant pixel size to scale with screen size. When you choose this mode, you get to select a reference resolution. The reference resolution is essentially the ideal resolution that we are designing the UI for. Once it has this reference resolution, the canvas scaler can calculate how different that is from the current resolution and scale accordingly. So my reference resolution is going to be 1920 by 1080. I'm also going to change the screen match mode to expand. You'll notice now that our crosshair looks really small, but it does now scale with the screen mode. In fact, when we make it really small, you can barely see the crosshair at all. So let's select our child text object now, and let's boost up the size of the font a little bit. I think I'm going to put it up to something like 57. And because I've chosen a 1920 by 1080 reference resolution for designing the UI, I'm going to change the display mode of the game view window in the editor from free aspect to 16:9. Which is the ratio between the width and the height in 1920 by 1080 mode. You can see now that as I make the window grow bigger and smaller, we stay with the same 16:9 aspect ratio. Let's also put the scene view into 2D mode and zoom out a little bit so that we can see that massive canvas. Okay, that looks good. So the next thing I'm going to do is I'm going to rename that text object to crosshair. Next up, I'm going to right click on our player HUD and I'm going to choose to create a new child UI object. This is going to be another text object which I'm going to call health. I'm then going to drag this out of the center of the canvas so I can see what I'm doing. And for now, I'm going to change the text to red and I'm going to boost up the font size a little bit so we can see what it looks like. And I need to keep opening up the size of the actual area because otherwise the text clips. So I'm going to put the font size up, I think, to about 76, which means I need to grow this a little bit more so it fits in. And I'm also going to change the font. You'll remember quite some time ago we imported some fonts, and one of the fonts that we imported was one called Zombie. So let's call that one up. There you go. Looks pretty cool to me. The horizontal and vertical alignment is fine. I want it to be aligned to the top and aligned to the left. And I'm going to change the text to say health 100%. Still need to open this out a little bit, don't I? And what I want this to do is be up in the corner of the screen, the top left corner. So I'm going to move that up here for now to where I think it needs to be. So let's say about there. And now at the moment, as I resize this, and I need to just put it back onto free aspect mode to show you what I mean. I resize that, it's not going to stay in the top left corner, and that's because we haven't anchored it to the top left corner. These 4 little triangles you see in the center of the screen means that this has actually been anchored to the center of the screen. So as we resize the screen, it's going to try and maintain its distance from the center of the screen. Whereas what we need to do is establish its relationship with the top left corner of the screen instead. So let's put it back in 16:9 mode again, and we can either move these anchor points ourselves like so, which is a bit laborious, dragging them all into the top left corner like so, or what you can do is you can choose one of the presets. So there's also a preset here. If we click in this little diagram in the top left corner of the Rect Transform Inspector, we can choose top left there as well. And if I set the display mode of the game view back to free aspect now, you'll notice that as we resize the window, it always stays in the top left corner, and that's exactly what we want. And what we're going to do now is kind of duplicate that, change the color, and on the right hand side of the screen, we're going to have the stamina readout. So I'm going to set the display mode of the game view back to 16:9. I'm going to duplicate the health game object that I created, and I'm going to call that stamina. And then I'm going to move that new object across to the other side of the screen, being sure to keep it aligned. And what I want to do is change the justification on this so that it's now aligned on the right hand side, not the left hand side. And I might need to just move that out a little bit until it looks okay. Yeah, it looks about right. Let's change that so it says stamina 100%. Okay, we're going to need to drag that back, aren't we? Like so. Currently, we have this stamina text anchored to the left-hand corner, but of course we want this one to be anchored to the right-hand corner so it maintains its relationship with the right-hand corner. So we'll just use one of the presets for that. In the rect transform, we'll click in that little diagram and we'll choose top right. And you can see that those 4 triangles that signify where the anchor is has now moved to the top right corner. Finally, selecting the stamina text again, I'm going to change the color of this to a green, something like that. Okay, next up I'm going to create another child text game object by right-clicking on the player HUD game object. That's the one with the canvas component on it. And from the UI submenu, choosing to create another text. This is going to be called the interactive text, and it's where text is going to be displayed when we move the crosshair over an interactive item. So if there was a medkit in the scene, when we move the crosshair over the interactive item, we want it to come up somewhere on our HUD and say medkit. Or if it's a weapon, say what the weapon name is and things like that. So we're going to call this interactive. This doesn't need to be anywhere near as big or as bold as our health and our stamina readouts. And I also want this to be along the bottom of the screen. So what I'm going to do is I'm going to drag it down here and I'm going to center align it. And I'm going to set the color to white. And I'm going to change the text to some placeholder text that's going to give us a basic indicator of what this might look like. So I'm going to say keypad, access code required. I'm going to leave the font at Arial so it's nice and plain, and I'm going to change the font size to around about, let's try something like 56, shall we? And of course I then need to open that out a little bit so that it fits in. That might be a bit big actually. Access, yeah, that's going to be too big, isn't it? Oops, I said keypad. That needs to be keypad. Not that it matters, it's only placeholder. And I need to move that down more towards the bottom of the screen. I think we're probably looking at something like that. And let's turn the size of that font down a little bit so it's something more like that, and then down a little bit more. That looks about right to me. Now, of course, at the moment, if I were to put the display mode of the game window in free aspect, we're once again anchoring that to the center of the screen. So as I move this around, it doesn't quite do what it should do. As we get a display mode that is higher rather than wider, you can see it starts to move up the screen, trying to maintain its relationship with the center of the screen. So what we need to do is we need to make sure that this is anchored to the center bottom edge of the UI. So via its rect inspector, let's see if there is a bottom middle preset, which there is. Let's hit that, and we should see now that as we move this around, it scales in size, but it doesn't move around. It still maintains its relationship to the bottom edge of the screen. Okay, so the next thing we're going to add is going to be some text that is going to display mission critical stuff. In the case of Creeper, it's going to be used twice. At the start of the level, it's going to say something big, like, I don't know, escape the level. And when you've got on the elevator and you've completed all your mission goals, at the end of the level, it's going to tell you that you've completed the level. So this needs to be quite big and bold. So once again, we're going to create another text object by right-clicking on the player HUD game object, and from the pop-up menu, choosing a new UI object of type text. And we'll call this mission. So it's like mission critical text. And once again, this is going to start off really small. So let's drag it down a little bit. We're going to make it bigger, not that big. I've just made it huge. Let me change the text to saying something like level complete. And let's scale the font size down so it actually fits within the box that I've allocated for it. Probably wants to be about that size, doesn't it? So let's also make it white so it stands out. There you go. We just want to resize this so that the text fits in it. Actually, I probably want to make it longer than that in case we want to put in much longer words than level complete. I want to center align that, and finally I want to move it up so it's in the center of the screen, and we can leave the anchors where they are. Maybe what we'll do is we'll move it down slightly underneath the crosshair, and I think that crosshair is a bit big as well, so I think we'll also reduce the font size on that as well. It only wants to be subtle, doesn't it? Selecting our mission text again, I'm going to set it to bold. Yeah, that looks better. Actually, I'm going to change the placeholder text to say something like escape in the elevator, which I think is exactly what I do say in the Creeper game. So that's what it's going to look like at the start of the level. Okay, so the next UI element and the final UI element I'm going to add to our HUD in this lesson is going to be an image that we're going to use to allow us to easily do screen fades in and out at the level start and at level end, whether that end is because you've completed the level or because you failed the mission. So we're going to select the player HUD game object again in a hierarchy, right click, and from the sub menu we're going to choose to add a new image. And you can see there's a white block on the screen. I'm going to rename this Fade. I'm then going to set this color to black. I'm then going to zoom out and increase its size so it consumes the entire UI. Doesn't look that pretty at the moment, does it? The great thing about the image component though is that we can set the color via script. So in a coroutine, we can simply set the alpha of this image from 0 to 1 to cause fade-ins and fade-outs. Now, something that is worth bearing in mind is that Unity's Retain Mode UI, which is what we're using here, has an order of render which is different from things like Photoshop. Normally, higher layers render on top of lower layers, but in Unity's UI, the objects that are further down the list underneath the canvas render last. So you can think of the UI as starting at the crosshair, rendering the crosshair first, the health second, the stamina third, the interactive fourth, the mission text fifth, and the fade last, which is why it covers up everything when we make it opaque. However, this might be what we want, but it might not be. So we might want, for example, imagine when the level is first started and when the level's complete, we might initially just want the mission text to be available so we can see it, and then sort of fade in the scene around it. And if we wanted to do that, we would just take our fade game object and drag it above the mission text. And you can see that that would give us this effect. So when I make the fade image opaque, we've still got the mission text showing up because it is rendered after the fade images. So that might be better actually, right? So when we go into the level, it says escape the elevator, and then slowly the scene fades in, and then the text will be turned off. Okay, so I think we've got our HUD exactly how we want it. What we need to do now is create a player HUD script where we can hook up references to all of these objects in the UI, and then we can implement functions so that other scripts, such as our character manager, can set the values, in other words, the text, to these UI elements. So let's call up the project view, drill down into our scripts folder, and in our scripts folder, drill down into the FPS controller folder, and in there we're going to create a new C# script, and I'm going to call this player HUD. I'm then going to drag and drop the player HUD C# script onto the player HUD game object, that's the one with the canvas component on it, in our scene hierarchy. If I select the player HUD game object, you can see there it is, our player HUD on the same game object as the canvas scaler, and the graphic raycaster. So let's now open up the player HUD script in MonoDevelop and start implementing our player HUD API. We'll move the curly brace down onto the next line because we're not animals, and we'll also get rid of the update function. We don't need that. We do need the start function, however. Our player HUD script is going to need to be able to hold references to those UI elements we've just created, the text elements and that image element. And it's going to need to be able to talk to those elements, and in order for our script to be able to understand those elements, we must include the Unity Engine.UI namespace. So underneath where it says using Unity Engine, we will add using Unity Engine.UI. Next up, we're going to create all of the inspector assigned variables that will allow us to hook up references to those UI elements on our canvas. So I'm going to create a comment saying inspector assigned UI references. The first one is going to be a game object that I've called crosshair, and that's going to be used to hook up a reference to our crosshair game object in the hierarchy. We're also going to need to store a reference to the text object that is displaying our health. As you can see, this is a variable of type text. Rather than storing a reference to just the game object, if we instead store a reference to the text object, we can use the text interface to set that text when the health changes. We will also declare another variable of type text that we will use to store a reference to the stamina text. We'll also create a third variable of type text that we can use to store a reference to the interactive text on our HUD. We'll also need to store a reference to that image UI element that we're going to use to do the screen fade. So you can see I declare a variable of type image and call it screen fade. Like I said, we're going to hook all of this up in the inspector in a moment. Finally, we create a fourth variable of type text that will be used to store a reference and change the mission text. Also, the way that this simple HUD is going to work is we're going to configure the HUD so that at application startup, the mission text is visible and the screen fade will be fully opaque. So we'll just see the text on a black background. However, we are going to want that initial text to disappear a few seconds into the game. Otherwise, it would get right in the way of gameplay. So next, I will create a private float, once again serialized so we can change this in the inspector, that we will use to set the mission text display time. I've set this to 3 seconds. This means at mission startup, we will see that mission text displayed for 3 seconds before it is disabled. Let's now create a public function that any script can call to tell our player HUD to display some mission text. As you can see, I've created a public function called showMissionText, which takes as its single parameter a string. we'll first check that we have a valid reference to the mission text UI object, and if we have, we'll set the text of the mission text UI object to the text that we've been passed into this function. We'll also make sure that as we've just set the text, that the game object is set active. In other words, if it's been disabled, that we re-enable it so it's visible. Next up, we create the hide mission text function. It takes no parameters, and this function can be called by any external script to instruct the player HUD to deactivate the mission text. As you can see, we make sure that we do have a valid reference to the mission text UI element, and we call the game object's setActive function passing in false. So we've now got two functions, one that allows us to set and display the mission text, and one that allows us to hide it. We'll now move up into our start function. Our start function wants to start off doing something quite simple. It wants to examine what the mission text display time is and call the hide mission text function after that time has elapsed, turning off the mission text. So inside the start function, I first check I have a valid reference to that text UI object, and if I have, I call the invoke function, passing in the name of the function that I would like to call, in this case hide mission text, and as the second parameter, pass in the number of seconds I would like to delay the calling of this function. As our mission text display time is currently set to 3 seconds, what this function will do is invoke the hide mission text function after 3 seconds have elapsed. The show mission text function and the hide mission text functions will be called at explicit points throughout our application when we wish to display text or hide text. However, certain things are going to want updating every single frame, such as our health and our stamina. So I'm going to create a function called invalidate to do that. As you can see, the invalidate function is a public function with a void return type. It takes a single parameter, a reference to a character manager. Our character manager will often call this function each frame, passing in a reference to itself. The invalidate function will use the character manager to fetch the health and the stamina of the player and then set that as the health and the stamina text of its associated UI elements. So first of all, we'll check we have been passed a valid reference to a character manager, and if we haven't, we just return there's nothing we can do. However, if we do have a valid reference to the health text UI element, then we set the text of that UI element to the string health plus, and then we add on to that what the current health of the player is. We do that by calling the health property of the character manager. This is a property we haven't implemented in the character manager yet, but of course it's simply going to return the health of the character, which is a float. So as you can see, I cast this to an int to get rid of any of the decimal places, and then I finally cast that to a string before appending it to the string health. Notice when I put the placeholder text in the UI element, I actually said health 100%. I'm actually not going to have the percentage sign. It looks kind of weird. I want it to just say health 100. And now we're going to do the same for the stamina. Assuming we have a valid reference to the stamina text UI element, I'm going to set the text of that element to the string stamina plus, and then I'm going to use another property of the character manager that we haven't implemented yet called stamina. This will return the stamina of the FPS controller, which once again is a float, so we cast it to an integer before then casting it to a string and appending it to the stamina string. So once again, we're not using the percentage sign, it will just say health 100, stamina 100. The next function I'm going to implement is the function that we call when we wish to set the interactive text. This will most commonly be called by the character manager when it realizes that the crosshair is over an interactive object, such as a weapon, a medkit, or a door. We'll call this function setInteractionText. Just like the show mission text function, it has a void return type and takes as its single parameter a string. Assuming we have a valid reference to the interactive text UI element, we first check if the text string that we've passed in is null. If it is, then it means we wish to disable the interactive text. So you can see, when this is the case, I set the text string of our interactive text UI element to null, and I also disable the game object of the interactive text so it disappears completely and isn't being rendered anymore. Otherwise, if the string that we've passed in isn't null, then we wish to assign that to our interactive text UI element and also make sure the game object it's on is enabled so it's visible. So as you can see, I say interactionText.text equals, and then assign it the string that was passed into the function, and then I fetch the game object of our interactive text UI element, calling it setActive function and passing true. Next up, it's time to implement our screen fading functionality using that screen fade image UI element. The first thing we'll do is we will create a public enumeration that will allow us to describe to the fade function whether we wish to perform a fade in or a fade out. So as you can see, I create a public enum called screen fade type with two members, fade in and fade out. Underneath the inspector assigned variables, we'll also declare some private variables. The first one is a float that will keep track of the current fade level of this image UI element. I'm going to set this to 1 by default at startup so that the image starts off fully opaque. In other words, the scene is completely faded out. We're also going to implement the fade as a coroutine, so I create an enumerator here called coroutine that will keep track of any coroutine that we've spawned. Inside the start function, I want to make sure that the alpha of our image object is set to whatever the current fade level is, in this case 1, fully opaque. So as you can see, I check first of all I have a valid reference to that image object that we're going to use for the fade, and because we can't set the alpha of the image's color directly, we have to fetch the color out into a local variable first, which I do here. Then I have to then assign our current fade level to the alpha component of that local color, and then finally assign the local color back to the screen fade's color property. Let's now create the fade function. Much like we've done before, there's going to be a parent fade function which isn't a coroutine. That means that any script can call it without having to worry about doing start coroutine. Also means that any script that isn't a mono behavior can call it also. We will have a second internal fade coroutine that will do the actual fading. So I create a public function with a void return type called fade. It takes 2 parameters. The first is the number of seconds we wish the fade to occur over, and the second is the type of fade we'd like to do, either a fade in or a fade out. Inside our fade function, the first thing we do is check our coroutine variable. If we find that it isn't null, then it means a fade coroutine is already running. We don't wish to spawn 2 fade coroutines for the same image. That will cause conflict, so what we do instead is we just stop any coroutine that is currently running. Next up, we wish to calculate what we wish to fade the alpha to. In other words, what we wish our current fade level to go to, either 0 or 1, depending on whether we're fading out or in. So I create a switch statement that is going to switch on the fade direction type that's been passed in. If we say we wish to do a fade in, then we wish to basically set the alpha of the image fade to 0. If the screen fade requested is to fade out, then we wish to set the target fade to 1 so that when we increment the alpha of the image object to 1, the scene is going to fade out to black. Next up, we wish to call our fade internal coroutine. This is the function that we haven't implemented yet. We'll do this in a moment. And it's the function that is also going to perform the actual fade. As you can see, it takes 2 parameters. The first is the number of seconds we would like the fade to occur over. The second parameter is what we would like to fade towards. And we calculated the target fade value above it. If we're fading in, this will be a 0. And if we're fading out, this will be a 1. Of course, this statement hasn't actually called the coroutine yet. We're just storing a reference to the enumerator in our coroutine variable. So in order to call this coroutine, we use Unity's start coroutine function, passing in our coroutine variable. Let's now implement the fade internal function that performs the actual fade. The first thing we do inside the function is check we have a valid reference to that image object in our UI which we're going to use to perform the screen fade. If we haven't, we can't perform a screen fade and we break from the coroutine. However, assuming that's not the case, we'll create a local float called timer that we'll use to keep track of time. And we'll also get what the current fade level is. Remember, we might have interrupted a fade that was already halfway through. So if we were halfway through, the current fade level would be 0.5, and that's what we're going to be fading from. And of course, we've already discussed we're going to be fading that value to the target fade parameter that's passed in. I store the current fade level in the source fade local variable. I'm also going to fetch the color from our image object. Remember, any changes that we make to the color, we actually have to do in a local variable. So that's why I fetch the color out of the image object into this local color so that I can manipulate it. If the number of seconds passed in is smaller than 1/10 of the second, I clamp it to the 1/10 of a second. We shouldn't want to perform a fade any less than that. And by doing this, I make sure that I avoid any divide by 0 errors if we should erroneously pass in 0 as the number of seconds. So next up, we're going to create a while loop that is going to keep iterating while our timer is smaller than the number of seconds that we've requested the fade happen over. Inside, we will increment our timer variable by time.delta time, so it slowly counts up to the number of seconds that we wish the fade to occur over. And then we will calculate the current fade level. The current fade level is simply a lerp between the source fade and the target fade. As the lerp value, we use timer over seconds. This will create a value that goes from 0 to 1 while our timer is counting up to the number of seconds passed into the function. Next up, we will set the alpha component of our local color variable to the current fade level that we just calculated. Of course, assigning current fade level to the alpha of a local color variable isn't going to do anything to the actual image object in our UI which is being used for the screen fade. So after after I've calculated the new alpha, I have to assign that local color variable back to the color property of our image object in our UI. Of course, this is a coroutine, so we must remember to yield return null in any while loop so that we don't tie up execution of the program. This loop will continue to iterate until timer reaches the number of seconds, at which point our fade is complete. And just to make sure that when we exit this function, the alpha of our image is exactly what we wanted it to be in the target fade, you can see we assign target fade to the current fade level and to the alpha of our local color variable, and then assign that color variable back to our image's color property. And that is our player HUD script complete. Let me save that off, go back to the editor, and let me warn you, there will definitely be errors because we're calling some functions in the character manager that we haven't implemented yet. And as you can see, we do have some errors. It's complaining that there is no definition for health and there is no definition for stamina in our character manager. So let's go and fix that now by opening up our character manager in MonoDevelop. And underneath where we declare the private variables, what we'll do is we will create some public properties. I'm going to paste these in because they're really simple. The first one is called health, returns a float, of course, which is our character manager's health. However, the stamina is not a property internally of the character manager. It's actually a property of the FPS controller. So you can see I say if the FPS controller doesn't equal null, then what we return is the FPS controller's stamina. The stamina, of course, is a property of the FPS controller that we implemented earlier. Otherwise, if FPS controller is null, I simply pass 0. I'm going to save that off, go back to the editor, and that should have got rid of our errors now. Of course, we can't run this yet because we haven't hooked up any of the references to the UI elements with our player HUD script. So let's select the player HUD script in the scene hierarchy, call up its inspector, and let's start dragging and dropping those references. So I'm going to drag over the crosshair and assign that in the crosshair slot, the health, and assign that in the health text slot, the stamina in the stamina slot, the interactive in the interaction text slot, the fade image in the screen fade slot, and the mission text in the mission text slot. Let's press play now and let's see what happens. Okay, well, the screen fade did not work. Why isn't that working? Oh, of course, I know why it's not working. Nothing is calling the fade function. That's what the character manager needs to manage from its start function. So what we'll do is we'll open up the character manager in MonoDevelop, and in its inspector assigned variables block on the bottom, we will create a new serialized field of type player HUD and store a reference to our player HUD so that our character manager can talk to the player HUD component. And we'll also go back to the editor and hook that up in a moment. And then at the bottom of the character manager start function, we'll simply say, assuming we have a valid reference to the player HUD, then call the player HUD's fade function and request a 2-second fade and tell the player HUD that we wish it to fade in over 2 seconds, which we know means it is basically fading out the black image. So let's save that off, go back to the editor and hook up the reference to this player HUD component in the editor. So let's select our FPS controller rig, scroll down to the character manager, and you can see we now have a player HUD slot which is currently set to none. So let's drag over a reference to our player HUD game object. Remember, what we're actually storing a reference to is not the game object, but this particular component on the game object, the player HUD script. And when I press play now, what we should see is escape in the elevator is on screen first of all with a black background. The scene should fade in over 2 seconds, and then the escape in elevator should disappear after 3 seconds. Let's see if that works. Perfect. We'll leave this text there for now so we can see what's going on, but when the level first starts, we are going to want to empty out things such as this line of text along the bottom, which is the interaction text. In fact, let's do that now. Let's select our interactive UI element. Let's make sure that this is an empty string at application startup. So let's press play again. Okay, so let's start running and see what happens to our stamina. Well, as you can see, absolutely nothing happens to our stamina because I've forgotten once again that inside the update function of the character manager is where it needs to talk to the player HUD and call its invalidate function. So let's once again call up our character manager in MonoDevelop, scroll down and find the update function. Right at the very bottom, I will say, if we have a valid reference to the player HUD, then player HUD.invalidate. And of course, this invalidate function takes a single parameter, right? It takes a reference to a character manager, so we just have to pass in this. So let's see if this works now. And as you can see, as I start to run, my stamina does indeed drop. I suppose we better get a zombie to attack us so we can see that our health goes down as well. Oh, little zombie scout girl is coming at us. That's not cool. Okay, so let's let her attack us. Yes, and our health is indeed going down. I'm getting absolutely destroyed here. They've all got hold of me, I can't get away. Okay, so there you see, health has gone down to 0, and in a real situation, game would be well and truly over. Okay, so I think I'm going to leave it there for this lesson. We've got a fully functioning HUD, and of course you're going to see it getting used a bit more once we put interactive objects in the scene, which will be coming up very, very shortly, and we're going to see that other line of text, the interactive text used, so that when our crosshair is put on something like a trigger, a door, a switch, or whatever, we're going to get a little message that comes up here that tells us what it is and what state it's in. I hope you had a good time and you enjoyed watching this video. I will see you next time. Bye bye now.